All right, guys, so we finished off with number 27 yesterday with using the quadratic formula. Let's see here. Yep. Any other questions on 26 or 27 using the quadratic formula to solve? Are we good with this here? Okay. And I would make sure that you do have the quadratic formula down somewhere. Now, 28, 29, and 30 is talking about finding the value of the discriminant, the type of solutions, and the values of the solutions. Now, the discriminant itself is b squared minus 4ac. It is the part that is inside the radical of the quadratic formula. Now, there's three ways that this value can work out to be. It is that b squared minus 4ac is greater than 0. And if it is, we have two real solutions. We could also have that b squared minus 4ac is equal to 0, which would mean we have one real solution. And we could also have that b squared minus 4ac is less than 0, which would be two complex solutions. Because the discriminant will really help us determine what kind of solutions we will have for these here, for whatever the quadratic equation is. Now, whenever we go about solving these here, finding the discriminant's value and determining the type and number of solutions, we do need it equal to 0 so we can know the exact values, or really the signs, the correct sign for A, B, and C. Is there one of these three in particular that y'all want to look at? (29). Now, we do want this equal to 0 so we can know the correct signs for A, B, and C. So to get this equal to 0, we would subtract x from both sides. And when we subtract x from both sides, we get that we have negative 2x squared minus x minus 6 is equal to 0. So at this point here, we do need to plug this into our b squared minus 4ac to be able to find the value of the discriminant and the number and types of solutions that we would have. Now, when looking at this here, what is going to be the value of b? It would be negative 1. Because our b term is going to be the term in front of x, because we're going based off of the ax squared plus bx plus c model. So b is the term in front of x, so it would be negative 1. Minus 4 times a, well, a is negative 2, and c is negative 6. And this should be negative 1 squared. Well, negative 1 squared is 1. And negative 4 times negative 2 is going to be positive 8. Times negative 6 would be negative 48. So this gives us a value of negative 47. Now, we could have typed this all into the calculator. We could have said parentheses negative 1 close parentheses squared minus 4 times negative 2 times negative 6, or written it out exactly as we see it, hit enter, and it should give us a value of negative 47. Any questions on this here? So the discriminant, is it greater than 0, equal to 0, or less than 0? So if it's less than 0, what do we have? 2 complex. Now on the test, that's all it's going to be asking for, because it's going to ask for the value of the discriminant, the number and type of solutions. Well, the value of the discriminant here is negative 47. Well, how many solutions would we have? 2. What type? And that's it. I'm not asking you to solve on this part. We're just having to find what it is, what the value b squared minus 4ac is, and the number and type, 2 complex, or 1 real or 2 real solutions. Questions on this here? 28. So if we look at 28, we still need this equal to 0 so we can know the correct signs for A, B, and C and their actual values. So the first thing we can do is actually subtract 4x squared from both sides. And what that'll tell us is that 0 is equal to negative 4x squared plus 5x minus 10. Now to find the value of the discriminant, we're going to plug in a, b, and c to b squared minus 4ac. Now the value of b for this here is positive 5, so we have 5 squared minus 4, well a is negative 4 and c is negative 10. And again, at this point here, we could type the whole thing into the calculator, hit enter, and it would give us the answer. Because if we did this by hand, we would have 25 minus 160, which is going to be a negative 135. Now, since the discriminant is negative 135, what do we have? 2 complex. 2 complex solutions. Yes. Because, I mean, most of the tests, we're going to be doing that because you're going to solve some by factoring, some by graphing, completing the square, quadratic formula. It's just going to be more on top of it. It's not. I took it out mainly because, 1, for time's sake, so that y'all will have enough time to finish it, and 2, you being able to prove or solve this and get the answers isn't really adding anything to showing that you can solve it more than the other ones already did. Really what I'm looking for in this is, can you find the discriminant and determine what types we would get from it, is all it's asking for. I just didn't see any extra point in solving for the actual values. Does that make sense? Any other questions? Any questions on number 30? Okay. 31 through 33. Create a perfect square trinomial by finding the value of c and then factor it. Well, for this here, c is equal to what? B over 2 squared. We can just look at 31. So here, c is equal to what over 2 squared? Negative 24. Well, negative 24 divided by 2 is, and negative 12 squared is. So the value of c is 144. Now we also need our set of parentheses squared. X. Now the number that goes inside with x is going to be whatever number we had before we squared it. Since it was negative 12, we will have x minus 12 squared. And for these here, you're going to need the value of c and it factored as a set of parentheses squared. Now you could write it like this here. You could have rewritten it back out as x squared minus 24x plus 144 if you wanted to do it that way, because I will still count that as finding the value of c. You just plugged 144 back in for c. I will include either one of those, because again, the value of c is 144. This here, you just plugged it back in I can see that you did find the value of C. If you just write the set of parentheses squared and don't include anything else, I will take off points for not finding the exact value of C. Does that make sense? So even if you did this all in the calculator, I'm looking for these two pieces. If you have both of those, you'll get credit. If you just include the 144 but not the factor, I will count points off. If you just have it factored but not the actual value, I'll count points off. Because I'm looking for some way, even if you rewrite it as this here, well, you included the value of C. I can count that. I will count that. Questions on 32 or 33? All right, the additional review sheet. Whenever we deal with powers of I, we can't have I to a power greater than 1. So what we can do is we can take the exponent and divide it by 4. And look at the decimal. Because if the decimal is 0.25, it reduces to I. If it's 0.50, it reduces to -1. If it's 0.75, it reduces to -I. And if it's 0.00, it reduces to 1. Which one of these do we want to look at? So A, we can take 27 divided by 4. And 27 divided by 4 is 7.75. We don't really care about the 7. We want this 0.75, which matches up with -I. Because again, we're really matching them up with the decimal numbers. Is there another one that we want to look at? We can look at I to the 6,971. Well, again, we're just dividing it by 4, which would be 1.75, because we have some number 0.75. Well, 0.75 is -I. Because the whole number is just how many times we went around the circle of 4. But we want the decimal, which tells us which one in the spot we are. 0.75 corresponds to -I. If we got a decimal of 0.5, it would be -1. And if we got a decimal of 0.00 or it did not give us a decimal, it is going to be 1. Because 0.00, the calculator is not going to show that. It's just going to show it as a whole number. Any other questions on simplifying each I term? Are you ready for the next part? Adding and subtracting. Well, we can look at A, because we can add the real numbers and add the complex numbers, because that's what we're doing here. 6 plus 4 is 10. And what's -7i plus -3i? It'd be what? Yeah, it'd be -10i. And that'd be it. This one too. Because we'd have 10 minus 10i. Clear. Now, we could also do this in the calculator. So if we look at E, which is parentheses, 189 second I minus 361 second I squared plus parentheses 71 second I squared minus 38 second I to the fourth. So we can type it in. And if we type it in and hit enter, it will tell us that this is 252 plus 189i. That's the answer. Just make sure when you're typing it in, you type it in correctly, because it can be easy to just retype the wrong thing in. But the graphing calculators will do it. Any other questions with addition or subtraction? Okay, let's look at multiplication. Questions with multiplication? Any one of these here? H? So we could do H by hand, or we can come over here, parentheses, 2 plus 3 second I, close parentheses, open parentheses, 7 minus 4 second I, close, open, 6 minus 2 second I.
So if you were to do this on paper, you would do 2 plus 7 plus 6?
So this here?
Or times 7?
Yep. Because if we did this by hand, we'd have to do the distributive property first. So we'll do 2 times 7, which is 14. 2 times negative 4i would be negative 8i. Then 3i times 7 is plus 21i. And 3i times negative 4i would be negative 12i squared. And we still have the 6 minus 2i. Now here, I squared is negative 1, so it's really making that positive 12. 14 plus 12 is 26. Negative 8i plus 12i is plus 13i. Now 26, we do it again. 26 times 6 is going to be, I'll step over here, because that'll be 6, carry the 3, 6 times 2 is 12, plus 3 is 156. And then we'll do 26 times negative 2i, which will be negative 52i. Then we'll do the same thing with 13. 13 times 6 is going to be plus 78i, and 13 times negative 2i is negative 26i squared. Well, again, I squared will make that negative 26 positive. 26 and 156 will be 182. And negative 52 plus 78i would be plus 36i. Yes, 26. Thank you. 26i. And if we look at the graphing calculator, it gave us the exact same thing. Any other questions on F through K? Because even though K has I squared and I to the fifth, the calculator can do the exact same thing. We'll just end up reducing those powers eventually. So any questions on F through K? questions on L through D? Yes. Which one do we want to look at typed in? We can do L. So when we type it in, we can't use the alpha y equals. We need to actually set them up in parentheses. So it'd be 8 minus 4 second I, because we're going to type the numerator in first, and then we would hit divide by 3 minus second I, and hit enter. So even if it is a single term on top or bottom, go on and just put it in parentheses anyways. It's going to help to make sure you do get the correct answer. Now, once you typed it in and hit enter, it gives you the answer. Most likely it will be in decimals. But what we have to do is hit math, enter, enter to bring it up as a fraction. Math, enter, enter will bring it up as a fraction. We'll want it in a fractional form. Any other questions on this here? Any other questions with division? We feel good with dividing these here. So like I was saying with letter N, when we type it in, you'll want to type it in as 8 plus 3i divided by 6i. Go on and put the parentheses around the denominator. It'll help you get the correct answer. If you leave them off, you will get the correct numbers but wrong signs. It will end up flipping the signs. Any other questions on these here? Okay, there is one other thing I do want to talk about, and that's our complex conjugates. I know it's not in there. But what would the complex conjugate of 6 plus 7i be? Uh-huh. 6 what? 6 minus 7i. About 14 minus 189i. Let's say negative 84i. Because the complex conjugate is just really changing the sign in front of the term with I, would be the complex conjugate. And I don't believe it's going to ask on the test for this, but if we did multiply the complex conjugates together, so 6 plus 7i and 6 minus 7i, the result would be what? Just a number. Because when we multiply them together, the I terms cancel out, and all we are left with is a real number. Any other questions on any of this here? Where the I is first? In standard form, we always write it in the form of A plus BI. Because we always want to write it in the form of A plus BI, our real part and our imaginary part. That's just written in standard form. A is always going to go first. Any other questions? And I mean, even if we did have it flipped with I first, I mean, you can rewrite it and find the conjugate. We good with this here? So I would make sure that you do have the formulas, I mean, the quadratic formula down, the steps for completing the square, which we did cover, the discriminant, our b squared minus 4ac, And if you do need a refresher, I would go back and rewatch, especially with graphing, to make sure you know how to plug it in the graphing calculator to graph it. Because we also have the zero product property. Any two or more things that multiply together that equals 0, one of them has to be 0. And going over factoring, but other than that, that is everything that will be on the test.